All right, so let's talk about the periodic table today. We're going to spend a lot of time on this moving forward throughout the unit, but today should be a good intro to how to use the periodic table, how it's arranged, what it's for, what an element is, so on. So first, let's talk about elements. The periodic table is the guide to all the elements in the universe. Now you might be asking, what is an element? The word element and atom are basically interchangeable. Element, though, refers to a specific type of atom. So elements are different types of atoms. Remember that all atoms are unique and have a different number of protons. So let's look at sodium. This is sodium. It's what's in table salt. It's not the same as salt. Salt that you eat on things is actually sodium chloride, so it's sodium with some chlorine. Sodium is a shiny-ish white metal. It's an alkali earth metal, very common part of the Earth's crust. It is an element. That means that sodium is only made of one type of atom. So every single atom in sodium has got the same number of protons and electrons, right? So everything in sodium has got 11 protons and electrons. Sodium is an element because all of the atoms have the same number of protons and electrons. Elements are the building blocks of the universe. There's nothing more simple than an element. There's nothing that you can break matter down into that's more simple than an element. Okay, so moving on. This is the Bohr model of sodium. You've seen these things before. This is just another way to represent sodium. And this is the periodic table key. So if you look at the top of the periodic table, this is the key that you'll find. The first part of the key is the atomic number. The atomic number, remember, tells us the number of protons and electrons that an element has. The next part is the symbol. So the symbol for sodium is Na. It's in Latin. Natrium is the Latin word for sodium. Natrium. Natrium. That's the Latin word for sodium. They put a lot of things in science in Latin because it's a universal language. It's a language that's dead, which means that it's not going to keep growing. No new words will be invented. And it's one that we can all universally speak all around the planet. So natrium is a Latin word for sodium. This other number down here is the atomic mass. We're going to work with that in just a second. That's the number of protons plus neutrons. Remember the parts that give an atom mass are the protons and the neutrons. So if you add those two things together, you'll get the atomic mass. So looking more closely at the key, you have 11 protons. How many neutrons do I have? The atomic mass equals 22.99. So the first thing you need to do is round this 22.99 up to 23. To calculate neutrons, I round the atomic mass up to the nearest whole number. In this case, it's 23. If it was 22.0001, I would round it down to 22. So we round the atomic mass to the nearest whole number. Then I subtract the number of protons. So I do 23 minus 11, which is the number of protons, and I'll get 12 neutrons. Sodium has 12 neutrons in it. So, to review, the first thing I do to calculate neutrons is look at the number of protons. Sodium has 11 protons. I know it has 11 protons because I look at the atomic number. I'm looking for the number of neutrons. To find the number of neutrons, I round the atomic mass to the nearest whole number, in this case 23, and subtract the protons. It's pretty simple. So this is the periodic table. We're going to work with this a bunch, and you'll have your own that you're going to color, and you'll make it kind of like this one that I've got. But let's look at it a little bit more in depth. So you'll notice that it's broken into several colors here. We have gray for the alkali metals, green for alkali earth metals, yellow is transitional metals. That's most of the metals you've ever heard of: iron, titanium, nickel, things like that. The other metals are in pink, non-metals are in blue, and noble gases are in kind of an orange color. So the reason these things are broken into these families like this, metals, earth metals, transitional metals, so on, is because of the way they react. So everything in this column, and if you remember back to our Sierra review, you might remember me talking about this. Everything in this column is called alkali metals. Alkali metals are very reactive. I'm going to give them a frowny face. They're very reactive. They blow up very easily. In my element kit that you've seen, they keep the lithium suspended in mineral oil because lithium, when exposed to water, will actually ignite. So you have to be very careful with these alkali metals. Hydrogen is extremely flammable. So alkali metals are very, very reactive. On the other side of the table, I have noble gases. These things are not reactive at all. Later on in the unit, we'll talk about why things are reactive or not, but just know for today that noble gases, they get a smiley face, they are not reactive. They're pretty chill. Helium is what they fill balloons with because it won't blow up. Neon is in signs. Xenon is in signs. They put these things around. They're very common for public use. Alkali earth metals are things that you definitely come in contact with. Magnesium is a staple part of your diet, so is calcium. The middle part is the transition metals. Now, transition metals are, again, things you're familiar with. Gold, mercury, titanium, tungsten, iron, chromium, magnesium, copper, zinc. All the metals that you've really heard of. Those are all called transition metals. The nonmetals are these blue part right here. All of this stuff in the blue is nonmetals. Nonmetals do not have metallic properties. We're going to talk about metals versus nonmetals versus metalloids in just a second. But the reason it's broken up this way is because it doesn't share any of the properties that metals have. So there's a pretty clear line between metals and nonmetals. The periodic table, if you look, and if you really focus on it, you'll see that it goes in atomic number order. So we start with 1 here with hydrogen, and we end all the way down here with 118. So we go across. 1 is hydrogen, 2 is helium, 3 is lithium, 4 is beryllium, 5 is boron, 6 is carbon, 7 is nitrogen, 8 is oxygen, 9 is fluorine, 10 is neon, so on and so forth. You also notice that as you move across with the atomic number, the atomic mass also increases. So hydrogen's atomic mass is a little tiny. It's only 1.01. Helium's atomic mass is 4.003. Lithium's is 6.94. So on and so forth. As you move across and the atomic number gets bigger, the atomic mass also gets bigger. So it's arranged moving this way, increasing atomic number. So as you move across from left to right, the atomic number increases. Some other interesting things about the periodic table to talk about right now. It is not complete. As you see, you've got some gaps. These have actually been completed at this point, but there's still some gaps. A lot of these elements on the periodic table are so unstable that they don't exist for a very long time. So once you make them, you put 118 protons and electrons together with some neutrons, they don't actually exist for very long. So they can be made in a lab, but they're very unstable, and so they break down into their constituent particle, proton, neutrons, and electrons very quickly. They're very radioactive usually. An unstable element is one that is radioactive. Radioactivity means that it's constantly emitting neutrons and radiation. The radiation is in the form of an alpha particle, usually, or beta particle, that causes really terrible things to happen to human tissue. We're going to talk more about radiation and some of the terrible uses of the atom later on in the unit, but know that these things down towards the bottom that have got a really high atomic mass are usually pretty radioactive. You're all pretty familiar with, I think, with uranium. Uranium is down here. Plutonium, these are both in atomic bombs as well. They fit, if you look, you've got these two little arrows. These things fit right in here. So because they're kind of weird, they broke them off of the periodic table and they stuck them down at the bottom. We'll work a lot more with the periodic table and with elements. I'm going to assign each of you an element that you're going to basically adopt, and you're going to talk all about the properties. You'll know all about the element that I give you. So we're going to work with this for a while because it's a very important topic.